All right, I'd like to begin with chapter 1, section 1. And chapter 1, section 1 is on measurement in physics. So we want to talk about a couple of things, define our basic units of measurement. So the building blocks are length, mass, and time. These are our fundamental units for measurement. The units we use are meters, kilograms, and second. Let's talk about definitions here. I'm using a different computer today and my scale is really off. I'm writing really large on the paper. I'm going to try to get used to it. Length is the distance between 2 points. All right, the meter was initially, some fraction of the distance from the equator to the North Pole through Paris. It's more recently been defined as a fraction of the speed of light in a vacuum. So 1 meter is defined to be the distance light travels in, let me see, 1 over 299,792,458 seconds. Okay, and this is just based on what we know to be the speed of light with the old definition of a meter, right? 2 9 significant figures. So now the meter is just defined based on. A kilogram is still just arbitrary. There is a block of a specific alloy to resist corrosion, changing the mass of it. That's on hand and is used as the standard for what 1 kilogram is. And the second is defined based on the period of radiation of a specific interaction on cesium. All right, so these are ways that they've been standardized, although it's still somewhat arbitrary. Right, there's no universal unit of measurement, which is why we use different things in the US when we talk about length So we could talk a little bit about the US system. And one thing I want to key in there is a lot of the times we associate pounds and kilograms, but pounds is a measure of force, or a unit of force, really. Some number of pounds would be a measurement. Right? And kilogram is a unit of mass. So we need to talk about the difference there. Force, we tend to think of as a push or pull. Right? It's an interaction where you exert on another object, whether a push or a pull. Mass, and the reason these two are related is they're often confused with the force of gravity, right? So, and the force of gravity depends on the mass of an object. Mass, I want to go with kind of the chemistry definition that everybody would be familiar with first. The amount of matter in an object, right? So I want to go ahead and mention that since that's probably what we've heard. All right, so that's probably what you've heard before. In physics, the mass of an object is its resistance to change in motion. So the more massive an object is, the harder it is to change its motion. And that typically has to do with it having more matter in it for the chemistry definition. All right, what else do I want to talk about in this first unit? I want to talk about derived quantities. So we talked about how we have kilograms, meters, and seconds as our basic fundamental quantities. But we also have derived quantities which can come from combinations of those, such as area, right, which would be measured in meters squared, right? It's a length on one side and a length on another side. For a rectangular object, it would be more complicated for something that's not rectangular, but you could imagine it in a very calculus kind of way, breaking it up into little bitty rectangles that fit in there, right? And integrating over the area of all these little rectangles. Another derived quantity, we have density, right, which is the amount of mass per unit volume. Per means divide, so when we say mass per unit volume, we would have kilograms per meters cubed, right? So inherent in that volume is another derived quantity, just like area, except it's three-dimensional instead of two-dimensional. And force. The unit of force has its own name. It's a Newton. And a Newton is 1 kilogram times a meter per second squared. And when we talk a little more about force, we'll see where that comes from and where that definition comes I want to talk a little more about precision and measurement and how that relates with scientific notation, but we're going to do that in another video that comes later in this chapter. This is pretty much it for section 1.1.